All right, this last lesson here is going to be on maximizing area again. So let's take a look at a variety of different ways we can do these kinds of problems. A rectangle is inscribed in a semicircle, and the radius is 3, which has the equation y equals square root 9 minus x squared. So this graph has that equation right there, and we need to draw a rectangle inside of it. A random rectangle, any point on it, so I'm just going to put it maybe right here in the middle of a box. I don't want it to look like it's on 2, just some random point. 2 vertices are on the semicircle. One is on the positive x-axis, so that looks good. Yep, positive x-axis. And one's on the negative x-axis. So that means the rectangle's got to look something like this. Okay. So if this is the point x comma y, then this here must be the point x comma 0. What are the coordinates of this point? If that's x to the right, then this one here must be negative x comma 0. And this point right here in quadrant 2 must be negative x comma positive y. Okay, and so what we have is a rectangle that is in quadrants 1 and 2. Okay, of course that can happen. So there's just going to be a couple little changes. We have to find or express the area here as a function of x. So it's a rectangle. A of x equals, how do you find the area of a rectangle? Base times height. So let's go take a look at our equation right here. So we have to write the base. I'm going to look at my picture for help, and the base goes from here to here. Here's the whole bottom. And how long or how wide is that bottom? X is that much distance. And that much distance is also x, so the length of the base here is 2x. Oh, that's a little different. 2x. And then the height. The height is just a single y. It's going from 0 up to y. But wait, I can't write a y. Maybe we'll speed things up here a little bit because as we saw yesterday, the y is going to be this equation right here times the square root of 9 minus x squared. So in this equation, it's very important to label this. This helps us throughout the whole bunch of questions here. The base is 2x, and the height is that fun formula. So if they ever ask, I'm sure they will, for the dimensions of the rectangle, there's the base and there's the height. Okay, graph and label the axes. So remember, we always draw quadrant 1. Okay, and are the axes x and y? No, they're certainly x, but in this case it's a of x. Now that's half of it. Remember, it says label the axes. Please spend some time and get this right. What does x represent? What does x represent? If you look at your picture, x is that much right there. X is not the base. X is half the base. Half the base. So just kind of pay attention to details as you do this. It's very similar to yesterday, but with some changes. A of x. What does this a of x equation represent? Well, they told me to write the area of a rectangle, so that's what this equation is. Area of the rectangle. Okay, it doesn't say this explicitly, but you have to find the domain so you know how much x-axis to show. So let's go ahead and do the domain. For this rectangle to exist, we have to have the base be more than 0, and the height has to be more than 0. The base, in this case, is 2x more than 0. So just divide by 2. Do I have to flip that sign? No, because I'm not dividing by negative. And the height is y, which is that fun equation right there. The square root of 9 minus x squared has to be more than 0. Well, how is a radical going to be more than 0? Well, as long as the stuff under it is more than 0. So I'm going to figure this problem out by examining this equation. Since it's a quadratic inequality, we're going to have to factor 3 plus x, 3 minus x, greater than 0, right? The whole inequality. Let's go ahead and put plus and minus 3 on the number line. Since it's greater, we're going to put open bubbles, and let's try our favorite 0. Is 9 minus 0 positive? Sure is. So let's make sure that the domain and the height, the base and the height here, are both in existence. So the overall domain answer is going to be x's that are between 0 and 3. Okay, so let's go ahead and label the x-axis then as 0, 1, 2, and 3. How do you find the y value, the maximum y height? Well, that's going to be in our calculator. Okay, so the x-axis gets labeled from our algebra. The y-axis we're going to get from our calculator. So let's go ahead and clear out the y value there. The equation is 2x times the square root of 9 minus x squared. And immediately go to window. Oh, good, 0 to 3. All right, let's try 10. Is 10 a good maximum height for the y? Oh, perfect. It does. Okay, so I'm going to write 10 as the maximum value height there for the y. The graph starts at 0, goes up, 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 and then it comes down. I'm not sure what's going on here. Does your calculator have a little space there? Because I'm seeing a little bit of an empty graph. And the question is, what's going on? Okay, well, these calculators are made with boxes. They're called pixels, and pixels can either turn on and be dark or turn off. So it can't really highlight half of a pixel. So I need to ask this calculator, are you trying to color in right there and you just can't because you can't draw small enough? And the way that I'm going to ask so that I draw a very accurate graph on my paper is with the trace button. And I'm going to ask the calculator about 3. Is 3 a good value? And the answer is, oh, yes it is, 3, 0. So it does touch the graph, it just is having trouble drawing because of the pixels. So on your paper, do not draw something like this. Bring it down to 3, put a point at exactly 0. Make sure your paper has a lot of information, and not just what you see, but what you ask the calculator. Okay, the next thing that we're going to do is use our calculator to find the maximum value there. Second, calculate maximum. And I think I'm just going to type left bound 0.5, the right bound 2.5. Ooh, I almost missed it there. You have to make sure you're wide enough. I think that's going to be okay, but in case you're not sure if the maximum is in there, you could always start again, and maybe I should say 2.9. Now I'm definitely going to be seeing the maximum there. Left, 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 and the maximum is, oh, let's round it 2 places nicely for the x value, 2.12, 9. 2.12, 9 exactly. No zeros needed because it came out exact. So 9 represents the y value, area, and 2.12 represents that x value. For what value of x is the area the largest? What x value? Well, the x value of 2.12. I'm going to say units because there's no units in this problem. Now, let's state the dimensions. Dimensions of a bedroom, dimensions of a rug, dimensions of a rectangle are the base and the height. Base by height. And the best place to figure this out is to go look at the equation that you made. When we started this problem, the base was 2x. And the height is the square root of 9 minus x squared. So neither of those are going to get this 2.12. To save base, I'm going to take my calculator and say second quit. I'm going to say 2x. So the base is 4.24 units. 4.24 units. And then what about the height? The height, I'm going to have to do a calculation, is the square root of 9 minus x squared. And the height is 2.12 units. And that will make the area be the largest. Okay, we're going to keep going here. Same rectangle, same picture, everything, except now they want me to make a new equation for perimeter. Express the perimeter of the rectangle as a function of x. Okay, let's just give everybody here a little reminder. Perimeter of a rectangle is 2 widths plus 2 lengths. Perimeter means you add all the sides of the rectangle. So we've got a bottom and a bottom plus a bottom and a top and a left and a right. We're going to call it P of x. Okay, let's take a look at the top and the bottom. Since the bottom is 2x, the top is 2x, that's going to make 4x. Plus, let's add the left and the right. I don't really want to say 2y, y plus y. So I can't say a y. I'm going to have to say 2. And then what does that y equal? Oh yeah, the square root. The square root of 9 minus x squared. Same rectangle, same dimensions and everything here. We just have a different equation we're making. Okay, let's graph P of x now. So now we're going to make a new graph, still using quadrant 1. But this graph is going to represent the perimeter. So is it x and y? Well, it's x, but it's not y, and it's not a of x. This equation is P of x. P of x represents perimeter of the rectangle. And x represents, well, x is the same. X is still there in my picture. It's not the base. It's still half the base of the rectangle. Half the base of the rectangle. How about the domain? Is the domain changing? Is the base and the height of this rectangle? Everything's still the same. So the x values are still going to be 0, 1, 2, 3. Okay. And we're going to use our calculator to figure out the maximum value here, the maximum y value. So let's go to y equals, and let's adjust our equation to the perimeter equation. All right, so we've got 4x plus 2 times the square root of 9 minus x squared. And the window is still 0 to 3. I'm not sure if 10 is going to be good. Let's go see. Oh, 10 is not high enough. 10 is not high enough, so I'm going to go up to 20. Oh yeah, 20 works. Oh. Okay, so first of all, let's just write 20 down. But now I'm not sure what's happening here. Is it having that problem again? Is it not being able to draw all the way down to 3? How do we ask the calculator if it really touches all the way down to the x-axis? We say trace, and let's ask about 3. Does it touch the x-axis? Please make sure you're doing this with me at home. Hit enter and say yes or no. Does it touch the x-axis? No. Look at that. It's like a hook. Up, 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 and it curves. And at 3, the value stops right there at 12. What if I type 3.1? Oh, invalid. Oh, well, I know why. 3 is not going to work. 3 makes it, is the endpoint. 3.1 is not in the domain. Okay, so that means this graph, oh, where does it start? Does it start at 0? No. Can you figure out where it starts? Let's ask the calculator. Trace 0, and the answer is it starts at 6. So it starts at 6, and it goes all the way like this, and at 3, it's at 3, 12. Okay, now we have to make sure that we use our buttons here to find the maximum very carefully. The left bound, I'm going to say 1. And the right bound, I'm going to say 3. I'm going to make sure that I go all the way to the edge there, click left a little bit, and the maximum value is 2.68, comma, 13.42. 13.42. And now we're going to answer some questions here. For what value of x? For what value of x? The x value is 2.68 units. You have to be careful when you're reading these questions. For what value of x is the perimeter the largest? So this is the perimeter graph. Point, 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 point. This is the point that has a perimeter that's the largest. But what x value gives that largest perimeter? And what is the largest perimeter? The largest perimeter is about 13.42, should I say units or units squared? Just units for perimeter. Okay, so make sure you understand what your calculator is saying so that you can draw appropriate graphs. Okay, this next page here is just a variety of graphs, equations, and some shapes that might be in there. And so what we want to do is label the diagrams and then write equations for them. So for example, this is a point on the curve. I'm going to call that point x comma y. So the base is x and the height is y. So the area of this rectangle here, a of x, would be base times height, x times y. Now you certainly can't leave a y in. You would have to replace y with the equation of that parabola. Okay, so we're just going to show you the basic setups, and then you would actually write the real ones if this was a real problem. Here's an example of a triangle. Here's a point on the graph in quadrant 1, x comma y. The base is x and the height is y. The area, a of x, of a triangle is 1/2 base, which is x, times the height, which is y. But don't forget, you got to take that y out because you can only have x variables. All right, number 3, here's a rectangle drawn in quadrants 1 and 2. So this is where it could get a little interesting. Here's a point x comma y. And so here's the point x comma 0. So x is the distance from the origin all the way to there. So that's x. So if I asked you what's the base of this rectangle, we wouldn't just call it x, we would call it 2x. So the area of this rectangle, a of x, equals base, which is 2x, times height, which is y. But once again, you would want to take that y out of the equation. Okay, and here's a very interesting one. There's a rectangle drawn inside of a circle. And so here's the point x comma y. X to the right and y units up. So when you're looking at this, what's the base of the rectangle? I know x goes from the origin to the right. Here's x, x to the right, x to the left, so the base is 2x. And then what's the height of this rectangle? Well, it's not just y because it goes y up and y down, so the height is 2y. So the area, a of x, of this rectangle would be base, which is 2x, times height, which is 2y. You don't need all those parentheses because this is times, times, times. 2 times x times 2 times y. Or you could even say 4xy. But in any instance, these y's would have to be replaced with the equation. Okay, I can't wait to see you tomorrow so we can practice this.